Assalamualaikum and good day to everyone. Thank you for the organizer, 5th IVCoSEI, for this opportunity. My name is TS Norshadila binti Ahmad Badela from College Community Sungai Siput, and this work is co-authored with TS Muhammad Nur Helmi bin Abdul Latif from UITM Cawangan Johor. Today I'll be presenting our study title, Extending the Technology Acceptance Model for AI-Assisted Learning in Technical Education, Evidence from SQL Instruction. Artificial intelligence is increasingly transforming teaching and learning, especially in higher education. AI systems are able to support personalization, provide real-time feedback, and adapt learning content according to learners' needs. As highlighted by Wang and colleague in 2024, AI-based systems offered personalized, data-driven support that adapts to learners. This makes AI particularly relevant for technical education, where students often require immediate guidance and structured feedback. In technical subjects such as database courses, SQL is a core skill. However, many learners struggle with SQL learning. SQL requires both logic, reasoning, and precise syntax, which can be challenging for beginners. Students often face difficulties translating problem statements into correct SQL queries. As noted by G. Mayer and Edwards, in traditional learning environment, feedback is often delayed or limited, which can slow down learning progress. Zhang also emphasized that the combination of logic and syntax precision make SQL particularly difficult for learners. This is where AI-assisted learning becomes valuable. AI tools can provide instant feedback, explain errors, and guide learners step by step while they are practicing SQL queries. According to Dahri and colleague, AI-assisted systems help bridge the feedback gap by offering real-time guidance and explanation, such as immediate feedback encourage self-directed and active learning, allowing students to learn from mistakes without waiting for instructor intervention. However, introducing technology alone does not guarantee successful adoption. To understand whether user accepted and intends to use the technology, we rely on the Technology Acceptance Models or TAM. Davis in 1989 proposed that perceived usefulness and perceived ease of use are the key factor influencing user acceptance of technology. TAM has been widely applied in educational technology research and remains highly relevant until today. In modern AI-based learning environment, interaction and user experience play a more significant role. Therefore, in this study, TAM was extended by including interactivity and satisfaction in addition to perceived usefulness and ease of use. Prior study, including Wang in 2024, have shown that interactivity and satisfaction are significant determinants of continued use in AI-assisted learning. This extended model allows us to better explain user acceptance in interactive, AI-driven learning system. Based on this framework, our study had three main objectives. First, to examine user acceptance of an AI-assisted SQL learning environment. Second, to validate the extended time construct in technical education context. And third, to compare acceptance between students and lecturers. This study employed a quantitative survey design. Data were collected from 128 participants, consisting of 88 students and 40 lecturers from technical institutions. A 5-point Likert scale was used along with open-ended questions for qualitative feedback. The AI learning tool was developed using HTML, JavaScript, and Open Router API, and was based on a printed SQL workbook used in the syllabus. Data analysis included descriptive statistics, reliability testing, and inferential analysis. The AI-assisted learning environment functioned as a prompt-based SQL tutor. Learners input SQL queries and receive real-time validation, syntax checking, and explanation. The tools also provide hints when learners are stuck without directly giving the answer. This design support guided learning while still encouraging independent problem solving. Reliability analysis was conducted using Chromebook Alpha. All constructs achieved value above 0.88, indicating excellent internal consistency. This confirmed that measurement instruments used in the study are reliable for evaluating AI-assisted learning acceptance. Here is the environment of the SQL AI ebook that has been used for this study. It has the prompt-based SQL tutor, automatic syntax checking, and real-time hints and explanation. The platform will respond to user answer and also give feedback based on AI response. It also have the show hints that will stimulate user thinking process. Here are the evaluation procedure that start with the briefing session to the respondents and guided them on how to use the platform. After tryout on the platform, user will answer the survey question. Here is the demographic of the respondent that comes from variety of background, from students and lecturers. Overall, the results show very positive acceptance of the AI-assisted SQL learning environment. Mean score for all constructive were above 4.5, indicating strong agreement. Among respondents, instructional relevance recorded the highest mean score, while perceived ease of use was slightly lower but very still high. The low standard deviation indicates strong consensus among participants. A Mann-Whitney U test was conducted to compare perception between students and lecturer. The results show no statistically significant difference across all constructs. This suggests that both students and lecturers similarly value the usability, interactivity, and usefulness of the AI tool. Overall, there was a broad agreement on the tool's effectiveness. Qualitative feedback further supported the quantitative finding. Participants highlighted the value of the real-time feedback, clarity of hints, and increased motivation. Lecturer noted that the tool reduced repetitive explanation, while students reported that learning SQL became more enjoyable. Some respondents suggested adding more advanced SQL scenario and improving mobile compatibility. These findings reinforce the role of interactivity in driving learner engagement. Satisfaction was found to mediate the intention to use the AI-assisted system consistent with prior research. Lee emphasized that interactivity and satisfaction act as mediator between system features and behavioral intention, which align well with our result. In conclusion, this study validates the extended TAM model for evaluating AI-assisted learning and SQL education. The AI-assisted SQL learning environment was well accepted by both students and lecturers. This finding confirmed that AI tools can effectively support technical education when usability, interactivity, and satisfaction are considered. For future work, we recommend expanding this study to other technical subjects involving larger and multi-use institution sample and incorporating learners' performance measure. AI integration in higher education also align with Malaysia National Digital Transformation Strategies, including My Digital and the National AI Roadmap. Here are the list of references that support these studies. Thank you very much for your attention. The AI learning tool used in the study can be accessed through the link shown. I welcome any question and comments. Thank you.